So let's do an example. Let's graph p of x equals negative the quantity x minus 2 times the quantity x plus 1 squared times the quantity x minus 3. So this is kind of nice because it's already factored for us. That would be a hard one to factor. That's a 4th degree polynomial. So I decided to find the y-intercept first. That's where x is 0 because it just looked like it was fairly easy to do. So I just plug in 0 and I would write it out exactly like this. So I'm going to write out this problem. All the stuff in yellow is exactly what I would write on my page if I were working this problem, and probably pretty much exactly what you should write on your page when you're working the problem. Remember, the game here is to learn how to write things out exactly right and systematically so you don't have to think about it too much, and then put the answers on the computer. It's not to try to do everything in your head and then put the thing in the computer. Okay? You're supposed to be writing everything out. So this is how I'd write this out to keep track of stuff. This will help you a lot if you do plan to continue to calculus. You definitely want to get used to doing this kind of thing. So I actually wrote down y-intercept, comma, x equals 0, colon, underline. Then p of 0. Always say what you're computing. Don't just write the right-hand side because that's the complicated side. That's where your focus is. You need to write down what you're computing. You're computing p of 0. So p of 0 equals negative, and then the opposite of negative 2 is what that really says, times 1 squared times negative 3. You multiply that out and you get negative 6. So the input is 0, the output is negative 6. So in this particular text, they want the intercept is, they want the x and y coordinate. So it's 0 comma negative 6, not just the number negative 6. Other textbooks will just use the number negative 6 and they say, well, it's the x-intercept, so we already know that the y coordinate is 0. But this textbook, they want you to write out both and put them in parentheses. So 0 comma negative 6. Okay, x-intercept is where y is 0. So we set y equal to 0. And then this is fairly easy because it's factored, right? So this will be 0 when one of the factors is 0. So that'll be x is 2 minus 1 or 3, right? And this minus 1, we call a double root because that comes from the x plus 1, the quantity squared, right? So you can think of it as x plus 1 times x plus 1. So you have the root negative 1 twice. So we call that a double root. But when we list our x-intercepts, there's only 3 of them, right? We don't list that negative the negative 1 twice. So we get the point 2 comma 0, the point negative 1 0, and the point 3 0. The 0 just comes from what I wrote down here. The y coordinate is 0. The x coordinate is 2, negative 1, or 3. Right? So that's what they want. That's the form they want them in, with the parentheses. Don't leave the parentheses out. You have to be careful with the parentheses because sometimes, let's back up a little bit. Sometimes they'll put the parentheses in for you and then put a box in between the parentheses, and then they just want 2 comma 0, negative 1 comma 0, 3 comma 0, like that. So you have to be careful of those parentheses. I've tried to get them to stop doing that because I think the students know that they need parentheses, but then they get sloppy about it, so it's kind of teaching them to be sloppy. But so far I haven't gotten them to change it, unless they changed it over the summer, which would be nice. I want them to take the parentheses off and have you put the parentheses in all the time so that you're not, assuming that they put the parentheses because on the last problem they did, something like that, and then you miss points. So I need to do tail behavior. The leading coefficient is negative. Is it -1? Yeah. If you were to multiply this out, right, if you were to multiply this out, you'd see the leading term would come from the highest power from each of these, right? So this is a x squared, this is a x, this is a x. So that gives me x to the 4th, and that gives me minus. So it'd be minus x to the 4th is the first term of the polynomial, right? The leading term. And so a sub n is -1, which is less than 0, and the degree is 4, which is even. So that means both ends go down. It's kind of like y equals -x squared as far as the ends go. Okay, so it goes like that. So I just write it like that. Now this part here, like y equals -x squared, you don't have to write down. That's just, I'm just noting that to you. But I would write down all this stuff exactly like this. I'd even circle it. Okay. And now I'm going to graph it. The graph I did in blue. The first thing I do is I graph all the points that I've found. So I have the y-intercept, I graphed that, and I had 3 x-intercepts. So I graphed all 3 of those, 1, 2, 3. Now this point here, what's going on, I can tell it goes down, then at some point it turns around, it goes back up, and then it has to turn around someplace and go back down. So I was trying to find a point that's near the top here, so I could graph it, because that's got to be an important point. Now, if we had calculus, we could compute exactly what that point is, exactly. But we don't, so I just use my calculator, and then there's various ways. You should learn how to use your calculator. I'm not going to go over all that. There's a manual for it. You can also just Google stuff. Oops, sorry. And so that's how I found this point here. I used you can use like a max function on your calculator, or you could just put the cursor on the curve and zoom in several times or something, round it off. So I put it's approximately 2.63.1. And then this here was the lowest point on this. We call it a local minimum. So it goes down until it gets to here, and then it turns and goes back up, right? And goes back down. And then the tail, it just keeps going down, because I figured that out here, right? Where is it? Right there. Right? Both ends go down. So that also tells me here it can't go above and then down, because there's no more points over here. So if it comes from here and it goes up to here, it must turn around right here and go down. That is pretty common when you have a double root there. So that's the behavior of a double root. It looks kind of like a parabola near that root. So it goes up and it goes back down again instead of crossing over the thing. So you might get confused if you see something like that, but then just do the practice ones. And if you see one, you get confused, you're up here and you're wondering, how do I get back down there again? And you forget this. You're supposed to just turn around there. So it just goes up and just touches the x-axis, then goes back down again. You can look at the tutor and it'll show you, press the button tutor or hint or whatever, and it'll show you what the graph looks like. You can also just put it in your calculator and look at it. In fact, you might want to put it in your calculator before doing any of this stuff, because then you already have an idea of how it's supposed to work out. So you'll know if you're making a mistake someplace, right? It's still important to be able to do this without a calculator, though, because for one thing, if your window's too small, you won't see all the important points. So if you calculate all these points, then these are important points. You can make sure that in your window, you're including all of these important points, right? and that'll usually give you a pretty decent graph. Also, if your scale is not a good scale for the graph, this squiggly part, right, could get flattened out so that all you see is, something that looks like that, and that's going to be wrong. It means you need to zoom in on that area to see what's actually going on. There's a squiggle there, right? Okay, so and on a lot of applications, you want to know these exact numbers, not approximations, and so people will actually compute these. So we're learning how to do that here. If you don't know how to use calc maximum or calc minimum, just Google it. It's not that hard. We used to have to search for the manual, but now it's a lot easier. So you adjust your window to include the points you found plus a little bit extra. Okay? And usually that'll give a really good picture. Higher level math classes, sometimes it doesn't, but that's because you have more tools at hand to figure out what's going on. And there's some graphs where you have to actually have two different pictures in order to see what's really going on. Since this graph has no asymptotes, why? Because polynomials don't have asymptotes. Keep that in mind. Polynomials do not have asymptotes. You can set x equals, this is just on your calculator. I'm just talking about the calculator. Set x min and x max using the numbers that you got for your points over here, plus a little bit in the x direction, a little bit in the y direction, plus and minus a little bit, right? To set the x min and x max, and then you zoom fit to set the y min and y max. So yeah, just if you don't understand what I mean there, Google the name of your computer, of your calculator, and zoom fit, and it'll explain it to you and probably give you an example so you can see how that works.